We know there are two types of friction. When an object is at rest, there may be static friction. When an object is moving, there's dynamic friction. Dynamic friction is always μr, where r is the normal reaction. Mu is called coefficient of friction and its value depends on the contact surface. For example, a force F is pulling an object of 2 kg to move at a constant velocity on a rough surface with mu equals 0.5. Find F. First, sketch the force diagram. Vertically, there's weight and normal reaction. Horizontally, friction is against the direction of moving. Since the object is in equilibrium, the resultants on both directions are 0. So vertically, R equals W, which is 20 Newton. Horizontally, F equals friction, which is mu R. This is 0.5 times 20, which is 10 Newton. A force F is pulling an object of 2 kg to move up at a constant velocity on a rough slope at 30 degrees to the horizontal with mu equals 0.5. F is parallel to the slope. Find F. First, sketch the force diagram. There's weight, normal reaction. Since the object is moving up the slope, the friction points down the slope. Resolve weight on both directions. Since the object is in equilibrium, vertically, R equals weight's vertical component, which is W cosine 30 degrees. It is 17.32 Newton. Horizontally, F equals friction plus weight's horizontal component. Dynamic friction is mu R. So F is mu R plus W sine 30 degrees. Put in the values, we get F as 18.7 Newton. When the object is moving, the dynamic friction is always mu R. However, the static friction can be from 0 to mu R. The maximum static friction is mu R. An object sits at rest on a surface with mu equals 0.8. The weight of the object is 20 Newton. If the surface is level, there are only weight and normal reaction on the vertical direction. Since the object is in equilibrium, according to Newton's first law, there should be no forces on the horizontal direction. So friction is 0. If the surface is tilted 10 degrees to the horizontal and the object is still at rest, there are weight, normal reaction and friction. Resolve weight on two directions. We get, R is W cosine 10 degrees, which is 19.7 Newton. Friction is W sine 10 degrees, which is 3.5 Newton. Mu R is 15.8 Newton. This is the maximum possible friction. We can see that the real friction is less than this value. If the surface is pushed to 30 degrees to the horizontal and the object is still at rest, the force diagram is the same. Resolve weight on two directions. We get, R is W cosine 30 degrees, which is 17.3 Newton. Friction is W sine 30 degrees, which is 10 Newton. Mu R is 13.9 Newton. The actual friction is still less than this value. We can see, as we tilt the surface higher, the normal reaction gets smaller, and the friction gets larger. Since mu is a fixed number, mu R also gets smaller. So there will be a point when the friction gets larger than mu R, and the object starts to slide down the surface. Let's look at an example. An object of 2 kg lies on a level surface with mu equals 0.5. The surface starts to tilt to form an angle with the horizontal. What's the maximum angle the surface can reach before the object starts to slide down? Let's sketch the force diagram when the surface is tilted at theta degrees. There's weight, normal reaction, and friction. Resolve W on two directions. Since the object is at rest, resultants on both directions are zero. Therefore, vertically, R equals W cosine theta. Horizontally, FR equals W sine theta. We know, Fr is between 0 and μr. Substitute in the values of Fr and R, we get W sine theta is between 0 and μ W cosine theta. Cancel W, and divide cosine theta on both sides, we get, tan theta is less than or equal to μ, which is 0.5. Therefore, the maximum angle is inverse tan 0.5, which is 26.6 degrees. So, when the surface is level, the friction is 0. As the surface starts to tilt, the friction starts to get larger. The more the surface is tilted, the larger the friction gets. It keeps increasing until it reaches μr. After that point, if the surface is tilted more, the object starts to slide down the surface. Once it starts to move, the friction stays at μr. An object of 2 kg sits at rest on a slope of 30 degrees to the horizontal. The coefficient of friction of the slope is 0.7. A force F, parallel to the slope, pointing upwards, starts to act on the object. Find the maximum value of F before the object starts to move up the slope. First, sketch the force diagram. At first, F is 0. So there's weight, normal reaction, and friction. Resolve W on two directions. Since the object is in equilibrium, vertically, R equals W cosine 30 degrees, which is 17.32 Newton. Horizontally, friction is W sine 10 degrees, which is 10 Newton. F will act on the horizontal direction and have no effect on the vertical direction. Therefore, the normal reaction, R, remains the same. So maximum friction is μr, which is 12.124 Newton. Now, F starts to act on the object. The horizontal component of the weight remains the same, which is 10 Newton. So when F is 1 Newton, friction is decreased to 9 Newton. As F gets larger and larger, friction gets smaller and smaller. When F is 10 Newton, friction is 0. When F is greater than 10 Newton, friction starts to point down the slope, because the resultant of all three forces must be 0. As F gets larger, friction gets larger. When friction reaches the maximum possible value, μr, the object starts to move up the slope. Therefore, the maximum value of F is 10 plus μr, which is 22.1 Newton. From this example, we can see, both the value and direction of static friction can change. It's all decided by Newton's first law of motion. When the object is about to move up or slip down the plane, it is in limiting equilibrium, and there's limiting friction μr.